Hey, hi. In this video, we're gonna see how to enable Carpenter on AWS EKS as cluster autoscaler. As you know, Carpenter is an open source cluster autoscaler that automatically provisions new pods in response to unschedulable pods. Actually, Carpenter evaluates the aggregate resource requirement of the pending pods and chooses the optimal instance type to run on them, right? So basically, as you see in this diagram, say that you have the pending Kubernetes pod or say AWS EKS pods, right? So those pods are currently in a unpend in a pending state. Why? Because it does not has any you know uh, running environment or EKS nodes. So generally we call those as unschedulable pod. Okay, and this event will be identified by Carpenter. So Carpenter is an another extra infrastructure layer on the AWS EKS or generally Kubernetes, which will identify this situation and tries to analyze the configurations of the AWS EKS cluster here, and it tries to spin up the required the another AWS EKS nodes where these unschedulable part can go and run on them, right? So this process is completely automated, and it is basically uh, completely managed by Carpenter application here, right? So this is one situation where it automatically scales up the nodes based on the demand of the pods. Yeah, there is another situations where you have over provisioned your AWS EKS cluster, which means you have an extra nodes where parts are not running, which eventually cost you, right? So in such cases, Carpenter also identifies such situations and tries to make that cluster optimal by removing the unnecessary nodes, right? So we're gonna see this scenario at a real time, and I'm gonna help you to walk you through the complete scenario, like how to configure it, how does the basically Carpenter behaves in the scale up situation and scale down situations. We will see at a real time. Okay, so with that note, what I do is I'm going to take you to the my AWS account here. So let me first go to my AWS account. So here I have already provisioned the AKS cluster. This is sorry EKS cluster. So currently this is 1.239 EKS cluster. That is Kubernetes version is 1.23 1.29. So in this scenario, what I do is I'm going to walk you through the all the step-by-step procedure that you need to do here. And I have already articulated a Helm file, that is a TXT file, which will help you to govern through the the number of steps, basically the number of commands that you need to run in a serial manner, and eventually you have experiencing this Carpenter performing cluster autoscaling jobs. So here I'm going to share you these files in my videos description. You can find it from there and try to mimic these scenario from your system so that you will have a hands-on experience here. First one is to spin up the EKS cluster, right? So here we need to have an EKS cluster. So before you go to there, before you spin up the EKS cluster, you need to have the AWS CLI installed in your system. So in my system, I have already installed AWS CLI. So I'm using AWS configure command to set my AWS account. So this is how I set the context of my AWS account. And I did a AWS STS get caller identity, which is actually to identify what is the identity that I'm using. I'm using IAM user, that is an admin user, right? And then I'm using EKSCTL utility. So basically this is EKS command line utility. It is an another command line utility that you need to install in your system. Then only you can use this, the CLI, that is EKSCTL CLIs. So I'm using EKSCTL CLI to spin up the EKS cluster because this is very easy to spin up the EKS cluster. You can also define the EKS cluster in an YAML file. So this YAML file looks very simple, something like this. So this is my cluster.yaml file. It's here I have given the cluster configurations, the name of the cluster, region, right? And then enabling the OIDC, creating a service account, then actually creating the node group. I'm creating a node group with the instance type t2.large. Minimum size is 2 nodes, maximum is 4 nodes. This is a demo. But in the production cases, you can change it according to your need. So once I run this command, it will take nearby more than 10 to 15 minutes. Yeah, close to 8 minutes. So this is where my cluster is ready. So once the cluster is ready, what I did is I have run the kubectl commands. Okay, so make sure that your system is also installed with the kubectl, which is basically again a command line utility through which you can interact with the Kubernetes API server. So kubectl get nodes. If you are getting this response, that is your nodes names, which means that you have set the context of your AWS cluster, that is EKS cluster, right? So this is the for freshly created EKS cluster. Say that you have already have a EKS cluster, you need to run the kubeconfig update configurations, or you use the AWS Kubernetes update config commands, which can eventually help you to set the kubeconfig file like this, and then you can run the kubectl get nodes command, which will return you this output. Okay, so with that, let's run the next command. That is, you need to run the AWS describe cluster, that is cluster name. So why I'm running this? Because if I go through the helfile.txt file, so here I have articulated the commands one after the other. You need to follow these numberings now. So let me make this close here. So this one, it has a step number 1, 2, 3 up to certain like nearby 10 steps. And you need to do these steps in a serial manner. First one, we need to set the variables, that is cluster name, region, account ID, cluster endpoint, and the AZs, right? So I need to get the endpoint. So to get the endpoint, I run the command called AWS EKS Cluster Describe. Describe the EKS cluster, you will get the endpoint URL. So this is the endpoint URL, which you can set it as a variable. And that's what I did it here. So this is the first command, we run it. And so once I get the endpoint, then what I'm doing is I'm setting my variables. If you see my selections, try to focus on my selections. Basically I'm walking you through those commands. So here I'm setting the variable, that is, since I'm running this in a PowerShell environment or PowerShell PowerShell terminal. So I'm setting my variables with using dollar signs. So here we have these many variables been set here. As I said, it includes cluster name, region, account ID, cluster endpoint, AZs. So once that is been done, we go to the next command. That is basically, yeah. So once that is done, let's go to the next command. That is basically create a IAM role and instance profile role for Carpenter nodes. So as you know that Carpenter is an cluster autoscaler, which means that it will make your cluster nodes up and down based on the situations. So for that sake, the Carpenter demands an IAM role, and it uses an IAM role as an instance profile role when it tries to spin up the EKS cluster nodes or Kubernetes nodes, right? So for that case, we need to run a CloudFormation template, which actually creates certain resources like IAM role policy and certain resources. So this is the CloudFormation template. I'm not going to walk you through this. So basically it has IAM role, and that IAM role is trusted by EC2 service because we are attaching it to EC2 instance profile role. I have policy, and then we are creating a certain services like you see that we are creating a event bridge, blah blah things. Basically, we are creating a set of resources through this one. So I'm not going to walk you through this in detail since we have a little time. Okay, so I'm going to minimize that. So basically we are deploying that CloudFormation. So we are deploying this CloudFormation using the CLI itself. So we have a AWS CloudFormation deploy. This is the stack name. I'm giving this stack name. This is my template name. This is blah blah. Okay, so I'm giving these commands and deploying a CloudFormation template, which actually creates IAM role policy and a list of AWS resources needed by Carpenter. Okay, so once we are done with it, so you see that you should be able to see the response, something like this, waiting to successfully created the stack, something like that. Once that is done, all right, so we go to the next command, that is create IAM identity mapping. So once the role has been created, next step is to add the Carpenter node role to the AWS auth config map. So we are actually creating a config map that is basically called as the AWS auth config map, which is a special type config map in the EKS cluster, and that we are creating with using the ekctl commandlet only. So this is the selection of command which I have executed here. That is ekctl create IAM identity mapping. This is a username. Okay, so this is my username. Yeah, so remember that. So this is basically, I have gone through a lot of pain here since I'm using AWS PowerShell. So make sure that you follow this syntax properly. So when I say syntax, in the sense, when you give the username, make sure that you give it in a single quote, something like this, that is system node, and then double braces. In that one, you give the EC2 private nodes, right? And this is backtick is nothing, basically breaking your very huge line into a multiple lines. Okay, so you can This is the backtick, which is basically breakdowns your single line into multiple lines, which makes a readable. And then the cluster name, ERN, this is the ERN role that we created by deploying the above stack. This is a group name, and we are actually assigning the two group names. Okay, so this is a wrong basically. So this is create EKSTL identity map. So I did it wrong, but later I corrected down the line. I'm going to show you that as well. It will take certain basically 10 to 30 seconds, and it will create the IAM identity mapping. You can check the IAM identity mapping by running a command called kubectl describe config map, and the output, you will be able to see the output something like this. So let's go to the next command, that is describe config map, right? So which is the output I'm showing you here. So this is what the output will look like. That is, if you can see here, you see the you have the config maps, that is groups, and this is what it happens. Okay, so if you try to run without this single quote, you will end up with a config map something like this. If you see here, that is a username, it does not has this curly braces EC2 provide DNS name, and eventually it will fail. And that's the reason I went through a pain, and then finally I have identified. Then I tried to delete it because I realized that that is a wrong. Okay, so I tried multiple times to delete that config map, but eventually I failed it. But no problems, and finally I have created a successful IAM identity mapping, something like this. So this is a final and correctly working IAM identity mapping. And eventually, so once I run the same command to check the configuration, that is config map. Now if you see here down the line, so it should be like this. Your config map should be like this, right? And then only the Carpenter will work as expected. Remember that. Okay, with that, let's go to the next command. The next command, if I go to the step number 4, that is create a Carpenter controller IAM role. So again, we have to create a Carpenter control role. First, to do that, first one, you will do EKSTL util associate IAM OIDC provider. So you need to run this command so that you can associate a IAM OIDC provider to the EKS cluster. Once that is done, you're going to create a so since the Carpenter controller runs within the EKS cluster, and the parts that is actually running the controller, that is Carpenter controller, needs a IAM service account. So basically, the Kubernetes service account. So to create the Kubernetes service account, we're going to run this command. This is the command. So that is EKSTL create IAM service account. We are giving the cluster name, the Carpenter name. Namespace, we are keeping it in a Carpenter. Then the role name, this is the role name that we have created above. You can try to correlate. Okay, so then the policy attached, that is nothing but policy I have created. So the policy I have created with using the CloudFormation stack that we deployed above. So once you run this one, it actually creates a IAM service account that is needed for Carpenter controller, and it will take certain nearby 40 seconds, and it will create a service account in your EKS cluster. So then you need to again create a AWS. So basically, I'm creating a variable. If you see here, that is actually Carpenter IAM role ARN. So I'm just above, we created a Carpenter role that is being set here as a variable. Yeah. So that is because we need that variable down the line. That's the reason we are doing it here. Okay, next one is basically so yeah, in this one, if you see, create the EC2 spot service link. This is an optional step. If you want to do, you can do it. So basically, to spin up the the extra nodes in the EKS cluster, Carpenter also can spin up EC2 spot services, basically, which is actually a spot instance, which is actually a cost-effective instance. You can try to use it. In this demo, I'm not using it, so you can run this command if you need, but this is an optional step. Let's go to the next command, that is install the Carpenter. Basically, that is the final step of creating the configuring the Carpenter infrastructure layer on the AWS EKS cluster. Now, before we create that, we have created a service account in the Kubernetes cluster. That service account, you can validate it again by running the command called EKSCTL get service account cluster name, and this is a namespace, and we are getting the output here like this. All right, so next command is basically is very interesting one. So now we are at step number 6. In step number 6, basically we are actually installing the Carpenter on the EKS cluster with using Helm charts. To run the Helm charts, you need parameters. So I am keeping those parameters in a variable. That's all. So basically don't get confused. So I'm running these 4 lines of PowerShell commands in one shot, something like this. So it creates basically, it gets the response, it creates Carpenter versions, so basically it's to create a Carpenter version string. Yeah. So basically we need this because, because we are using the Helm chart to deploy the Carpenter. So we need a Carpenter Helm chart versions. And that is what we are doing it if you see here. Yeah. So next command is, this is the one of the suggestion from AWS that you need to do a Docker logout. So you need to run this Docker logout command as you see here. All right. The next command is, basically to install the Carpenter with using the Helm charts. First one, you run a command, something very big command. This is the one single command I run it in one shot, and it created the required infrastructure in the AWS EKS cluster. Right. So here Helm update, install the Carpenter. This is the the public URL. You see that. Right. Then the version is, this is the version which we got above. If you see, the version is 0.36 version. Namespace, you're creating the Carpenter namespaces. Right. So, and basically telling the Helm to create a namespace if it does not exist. Then you are actually setting the certain parameters, that is a service account. So you are creating the service account, nothing but the service account that we created above. And then the cluster name, this is a cluster name, endpoint variables, then you have a cluster variable. So all these are giving it as a input here. The next one is basically set the the drift equal to true wait. Yeah, so you can append the wait so that it can wait until deployment gets completed, or else it's gonna skip it. So basically putting a wait parameter to this Helm upgrade is needed. You see that it has taken me almost like close to a minute, and it has deployed the Helm chart on the EKS cluster. Now time has come to validate if the deployment of the Helm control. Basically, with this command, you are actually running the installing the Carpenter controller on the EKS cluster, which is basically a foundational infrastructure layer of Carpenter application. So here you are actually validating that running the command, that is Helm list Carpenter, Helm list get pods in the namespace Carpenter, then get deployment. So this is where the deployment. You see that. So I'm getting the deployment. So deployment is green, and getting the namespace. Namespace is created, right? So, and it just check the pods. You see that the Carpenter pods are basically, we are creating the basically this Helm chart creates two replicas of the Carpenters. So make sure that you have a minimum 2 nodes on the EKS cluster. So these are the two parts getting created. The next one is the just checking the deployment. Right. So next, go to the next command. So now we are set with the Carpenter controller. Let's go to the next command. That is still not enough. So we need to also deploy a certain other configurations related to the Carpenter, so that the installation of the Carpenter infrastructure gets completed. So for that case, we need to create a one more namespace, that is create a namespace, that is a workshop namespace. And then next command is basically provisioning the first. See, Carpenter really works behind the scenario. So basically, so if you go to the basic.yaml, so once the Carpenter is been created, so Carpenter will also create two different pods. One, if you see here, one is basically node pool. In the node, so what is this? Basically, these are all the the Carpenter related objects, Carpenter related Kubernetes objects, node pool. The other one is down the line, that is EKS node class. So what is this? Basically, these are all the nothing but definition telling Carpenter, saying like, whenever there is a situation of creating a new nodes, what is that I need to do? I need to wait for 30 seconds and then start creating the EKS nodes of certain configurations. So that definitions will be defined in the node pools. If you see here, so that is a disruption is nothing but when is the disruption is, basically start creating the nodes after 30 seconds of the disruptions. Yeah, so there are all the conditions, and the limit is up to 10 CPU, right? So how many, basically, how many number of CPUs that you can create, right? 10 CPU like that. So it is basically telling that, how much number of node pools that Carpenter can create for your cluster pod application purpose. And you also specify certain specification. You see that is, what kind of instance category, what kind of architecture, what kind of capacity of nodes it should create, like that. And then the EC2 node class is basically, when it creates a node, that is pinned up by the Carpenter. So in which security group and in which subnet it has to create. So these are all the informations are given to this Carpenter. Yeah. So what are these? Basically, nothing but Kubernetes object that is helping the controller to do its job. That is, do the cluster autoscaler. So we are just deploying that. You see that we are actually deploying that YAML file by running the command kubectl apply, and it got created those two those two objects. Once that is done, so now we are set with the infrastructure. Now time has come to start the testing. So to do the testing, you need to have a dummy application, in the sense deploy the container application on your cluster. So this is a container application. If you see here, this is a deployment, and name is inflate, namespace is workspace, and the specification of the pod is like replica 0. For now we are keeping replica 0, and we're gonna replicate is basically later. Then if you see down the line, so basically it's a container, and so here is the magic, right? Since this is a dummy application, to study the Carpenter capabilities, so we have kept the resource of a particular pod equal to 1 CPU, which is too high. So but for now, because I want to mimic the scenario, right, so we have kept it very high like this. So we deploy this basic the deployment like this, and it is got created. So these are all commands are already been mentioned here, if you don't need to worry. So we are at the line number step number 9. Now at the step number 10. So in the step number 10, so if you see, right, in the basic deployment, the number of pods or basically replicas are 0. Now we suddenly run a kubectl command to scale that deployment. So Kubernetes command to basically kubectl commands to scale the deployment is kubectl deployment, kubectl scale deployment namespace workspace, right? And then what is a pod name? That is inflate number of replicas, that is actually 5, which means you are shooting the the number of pods running in the cluster, right? So then I started to scan the logs, just to curious to just understand what is Carpenter is doing on my cluster. So to run the command kubectl Carpenter logs, this is the basically this is what the logs it's gonna scrape us. You see that, so this is the logs you can study basically. And then I tried to see the what are all the namespace got created. So these are all the namespace got created after that. Then I checked the number of nodes, because my definition of my cluster says that at the base, at the minimum size, I have a 2 nodes. So my 2 nodes are spinning. Then I checked the parts. So I checked that all the parts got occupied, because the I am using the T2 extra large. So those 2 nodes are enough for running these 5 pods. And then it started to run. Okay, then again I was curious to explore the node, so I did that. So basically you can run this command to see the logs of the Carpenter. Yeah, and then what we do is we're gonna again, I see that it is running. The next command is I suddenly shoot the replica set to 10, in the sense we are basically multiplying the pods into 10 times. Okay, and when I did that, you see that pod get pods. If I check the status of the pods, there are 5 parts. There are few parts are going in a pending state. If you see here, the first 2 parts are in pending, and then these are all the basically 4 parts are in pending. Why? Because I'm using two.large, which is basically basically has the 8 core CPUs. So in that one, 2 is already used by Kubernetes management control layer, and then after that we deployed the 5 parts. So those 5 parts are getting basically we deployed the 5 parts of example application. Those are getting occupied here. So in total, so we are remaining with the with the 4 4 pending, because these 4 the parts, application parts, are demanding the 1 core CPU. So basically the cluster is less of 4 core CPUs. Right, then so then the where actually the Kubernetes Carpenter autoscaler plays its job. You see that when you run this command, you should be able to see a message something like, you see that nodes claim. You see, if you read the messages here down the line, you should see that nodes, basically there is a activity to claim the nodes. Okay, and suddenly when I run the command, that is kubectl get nodes, I see that the nodes number now increased to 3, though I have the threshold of 4 only. So earlier it was 2, now it got increased to suddenly to the 3. right? Which means that it has scaled a node to the requirement, yeah. And then I suddenly check the number of the status of the pods all got started to running, which means that there was a scarcity of nodes or basically resources. Then Carpenter come in picture and it spinned up the new EKS nodes. Then the required resources for the pod got available, and then the pod started to run. Or basically, the scheduler of the Kubernetes cluster scheduled those pods on the newly created EKS nodes. Right. Then again, what I did, this is basically scale up. Now scale down. So okay, this is a scale down. So what I did is, again, I decreased the replica set to 5, which means that only 5 nodes, 5 pods, which means that it is basically extra nodes. Okay, then again I tried to study the logs, and then I again run the command, that is kubectl get nodes. Then it is again decreased down. So basically we saw that it actually scaled up and scaled down. Okay, so now let's try to show you in front of you. Basically we can see that here. Let's try to increase the replica set to 10, and we see that the scale up basically, yeah. So currently it is 5, and let me run this to 10. So I'm just shoot up the replica set to 10 and try to see the status of pods. So currently the pod status, if you see here, so there are pendings. There are basically 4 pending, right? So let's try to check the nodes. Let's see what is Kubernetes, the Carpenter is doing. It is still taking time. Why? Because as you see, right, we have in the definition we have told Carpenter, hey, you need to wait for 30 seconds when the situation occurred, right? So that's the reason there is a delay here. So you can try to check the one more time the nodes, right? So basically parts are coming up, and we need to wait for certain amount of time, right? So after 30 seconds, Carpenter tries to spin up the nodes. If you see here, now suddenly the node got shoot up here, right? So earlier the node was 2, now it is suited to the basically nothing, but it scaled up. It scaled up the nodes to 3. Now check the status of the parts. So if you check the status of the parts, all the parts are running, right? So now go back to the AWS EKS AWS console. So this is my AWS console, and if I go to the EC2 spaces, EC2 service page, I'm in Oregon region. My cluster is also in Oregon region, so don't get confused. And you see that it has spinned up the extra nodes. If you see here, and you see that at the base, my node instance type, that is EKS node instance types, are t2.extra large, but now it's spinned up, that is C6 to extra large, yeah. So this is how it gone. Now let's try to do one more game, that is actually decrease to 5. So I wanted to show you this demo in a very hands-on manner. So this is what I'm doing it here. So you see that suddenly it killed the 5 pods. Now the number of pods equal to 5. And if you check the nodes, get nodes, basically you should be able to see only 2 after 30 minutes, 30 seconds, yeah. So wait for a 30 seconds and you should be able to see the pod. I know the basically Carpenter doing its job, that is decreasing the number of nodes to back to the 2, right? So we need to wait for 30 seconds. If I can refresh it here, you should be able to see that status going down here. Or you can also try to check the logs of the Carpenter here. So by running this command, that is kubectl namespace kubectl logs from the namespace Carpenter, like that, right? So, and wait for a couple of basically a couple of minutes, and you should be able to see the nodes going down. Here you go, right? So now the nodes count equal to 2, which means that I have shown you the dynamically twice that it scales ups and scale downs based on the situations. And now the pod gone, yeah. Basically now it has removed the nodes. Okay, all right. So with that note, I have shown you the things need to be shown in this video, that is how to configure the Carpenter, and real time showing you the demo of how does the Carpenter scales ups and scale downs the the EKS nodes based on the situations in the EKS cluster. All right, so with that note, thank you very much for watching my video. Kind request, please do subscribe my channel. That would really encourage me a lot. With that note, thank you, thanks a lot, and see you in the next video.